Hello, everyone. It's Ahmed Lyahou. I'm from the company Intersec, an early warning system provider. Our presentation today, should I wait for people? Okay. Our presentation today will be about how AI can impact our use of early warning system, or in CAP way, how AI can help us build a CAP message or CAP alert in an effective way. A quick view of the company, Intersec. It's founded in 2004. We have 20 years of presence, 10 years working with government on different systems, and in particular in early warning systems, public warning systems. We are present in 50 countries, mostly in Europe for the early warning system and public warning system, in several countries, in France, in UK, in Slovenia, we are covering most European countries for their public warning systems and early warning systems, implementing multiple channels, of course, broadcast, LBSMS, sirens, TVs, radios, and so on. This is the quick review of Intersec, and now I can go through the presentation. As per today, we all have early warning systems, public warning systems, but we are more on a reactive way of working instead of proactive or predictive. What does it mean is that we have an alert to build. The person responsible of building an alert, and the alert will connect to the system, will build the alert, will compose the message, or will use a pre-existing message, will submit the alert for validation, and then it gets validated and submitted to the population or disseminated to the population. We have a very limited view or gap view on what's happening on the field after disseminating the alert, or even before disseminating the alert. Even when we have some data from the field, like river sensors, meteor data, and so on, we don't have a real correlation between all this data. So we use maybe 1, 2 of them, but we never correlate all the existing data to enhance our early warning system or public warning system usage. And as Benoit mentioned, is that when we send an alert, we should never we should never send an alert without being sure about the risk, about the impact. Otherwise, we will lose the public trust, because we are sending alerts to a public. It's always good to alert the population. In some moment, if we are sending alerts without really being sure, and if the population is receiving alerts, and after that there is really no real impact of the incident or the disaster, we will start losing their trust in the system itself. So now, why should we change? Or why should we change our way to work, or our way of thinking, or our way to build the alerts? The most important point is that now crises are really increasing in Europe, in the world at all, due to climate change, due to political issues between countries. So we need really to enhance or to advance the system. We have a lot of data today: meteor data, video surveillance data, satellite data, like field awareness data. We have a lot of data sources. We can use them to enhance our way to work. Now, authorities must act faster. This is a fact, even now, even before, and even in the future. Okay, sorry. So this is most reasons how should we change our way of working. And as per today, the most effective way of change is using AI. AI today is everywhere. We are using it every day. So why not using it in our public warning system, early warning systems? Before going on the presentation planning, I think everyone here knows what's AI. So definition of AI is how to make the machine thinks like a human, or how to reproduce the human mind into a machine. This is like a very quick definition. Why AI today? Of course, since the beginning of all the LLM, ChatGPT, Gemini, and so on, AI is used really everywhere by everyone, mostly everyone in the world. to help us in daily tasks, maybe in work, in everything. So this is why by today, we think that it's really the time to use AI in our early warning systems. Our presentation will focus on mainly how AI can help us, and especially how Intersec is viewing implementing AI in its public warning system and early warning system. How AI can make us really better is, first thing, it makes us faster. It can help us be fast in our reaction by real life simulation trainings, building the alert, selecting the channels, drawing the zone of the alert based on information from the field, and so on. It can make our system adaptive. After starting the alert, we can really gather the information from the field also and from all sensors, meteo data, and adapt the alert, ongoing alert in real time. And the last point, which is which is really the objective, the final objective, is to make everything automatic or proactive in our system, till, of course, the validation of the alert. We will never let our system disseminate the alert to the population. We will let it gather data, build the alert, and ask for validation from a human. Let's see those points one by one in details in the next slides. First thing, make the alert or the system faster. How can we make the alert or system faster? We have really here two main axes. The first one is to make the person using the system faster, train him. We can either refer to the classic way of training people, organize a training every week or every month, one-day training to our people and authorities or the people using the system, to keep them really aware on how to use the system. Because sending an alert sometimes, like waking up a person in 2 a.m. to ask him to draw the alert, to build an alert, disseminate an alert to the population, it can take some time, like 10 minutes, 20 minutes, 30 minutes to build the alert, to connect to the system, to build it, to ask for validation and validate it, of course. So by using the AI, trainings can be more effective and more easy and less costly, of course. How can we do this? The system can build simulation or use simulatory use cases. For example, it can just ask the persons in a proactive way, that we can build a training model for our people and ask them in a proactive way to answer questions, like to build some use cases and try to evaluate the response of the user of the platform and make sure that the user will stay trained, well-informed on how to use the system, how to build the alert, what are the most important channels to use, and so on. So this is the first way how to make it faster, to train the guys. Also, we can evaluate them. We can build exams, multiple choices questions for the end users, and then try to evaluate our users, whether they are really aware of the system, whether they are really well trained about the public warning system and early warning system at all. So here, this is the first way how we can use AI to make our alerting system faster, is by training the users. The second way is by making our platform, our system itself, better. Like, for example, here we have a gas leak or gas explosion in some places. This is a very urgent or very critical incident, and we need to be fast to react to this incident. Our AI or the AI at general can help the users of the system, the platform users, to build an alert based on this information. So we know where the leak happens. So approximately we know which zone we need to alert. We can gather some data from the meteo, like the wind direction, the wind force. So we know where the gas or where the leak will go in the next 15 minutes, in the next 30 minutes, and in the next hour. This will help us to build the zone. The first thing, we know what's the incident. It will help us to build the message. We know that it's very critical, it's extreme, and it's actual, it's happening now. So we can choose the channel, which will be mostly the cell broadcast in this case, and so on. So here, the AI, based on this information, we can really make it automatic to building the alert from zero. Like, we just need to, in our current implementation in Intersec, we have like a chatbot, we have an agent. The user needs just to talk to the platform in human language, and it will build the alert, and it will submit it for validation, of course. Another example of an incident that needs a fast reaction is flash floods. Sorry. For example, we have river sensors. We know that it's raining. River level is really increasing very fast. It's a danger. It's imminent danger. AI can really, in this case, also build an alert when it's the same workflow, a different type of alert or different type of message. It can select the channel, it can build the message, it can build the zone, and it can ask for alert validation. So here is the first section on how can we make our system better in building CAP messages. Sorry. The next step is make it dynamic or make it adapt to the situation. Once we start the alert, whatever is the channel, SMS, cell broadcast, sirens, situation may change on the field. So we can start an alert of fire in some area based on the wind and some other information, maybe video surveillance, drones, other thing. Social media, by collecting data from people posting on social media, we may need to adapt our alert in real time and fast. By adapting alert, for example, if we have a fire, we have an evacuation plan sent or submitted to the users. If there is one road which is congested or the fire went to this road also, we need to adapt our message to adapt our evacuation plan. In this case, we have our alert, our initial alert built. We have some data collected from sensor, meteo information, videos, still social media, traffic information of the country, if we have such a system in the country, or from open data or from like paid data sources. And we can build or adapt or update the alert. And in this case, we will send just a CAP update message to update our alert by updating the message, evacuation plan, alert zone, and alert duration, of course. If initially we put the alert duration to 2 hours or 3 hours, and we discover that maybe the incident is taking 6 hours, we need to update it automatically. And this is a second use case or example, as I said, for a wildfire. So initially, we built an alert. We know what's the zone, we know what's the message, and we know exactly what's the evacuation plan, which is those roads in the map. If we collect data and we discover that one road in the evacuation plan is blocked, we can automatically update our alert by sending a new message, extending the zone, including other people that were not notified in initial alert, and of course, updating the evacuation plan. The third main axe or main point of enhancing our early warning systems is making it all automatic. When I say all automatic, of course, I'm not excluding the human factor. We still need the human to review, to validate the alert. And here we can collect whatever data we have. And when I say this, it's sensors, camera, social media, street information, and especially data from previous alerts. When we send an alert, we gather information from the field, we analyze how population reacted to our initial alert, how they moved, how much time it took them to evacuate the place or evacuate the area. Based on all this information, we still can build a full alert from the initial detection or of incident, or even prediction of incident. If we have meteo information, we can predict a flood in 3 days. In this case, for example, we can choose SMS as an alerting channel because it's not imminent, it's not critical. We can use SMS. It may take 1 hour to be disseminated to all the population in the zone, but it's still fine. It will be informative. We can send links, we can send photos, we can send any like evacuation plan with a map in specific channels. So in this case, AI can build an alert from the beginning, of course. It can select the zone based on meteo information, on other information. It can build a message based on the criticity. It can select the channel based on the urgency also of the situation and based on which is the more relevant to send the alert to the population. And it can really build the alert from end to end. As I said, we are not excluding the human factor. Even our system or any alerting system can help building the alert, but we still need this human factor to validate the alert at the end and to disseminate it to the population. a quick conclusion of what we have seen here. So AI is really transforming the crisis management. And today, AI is not the future, it's really today. We are using it, it's everywhere, and we need to use it in our CAP generation, in our early warning systems. When we build it, we need to think it initially to use the AI. Sorry. It really extends from the technology to people, and this is what we presented, is like AI, it really can help us enhance our early warning systems by letting them analyze data, building alerts, but it also can enhance our way to work. It can train people, it can make the cost of training very low, and we are working with some customers regarding this, because in reality, like an agent who is responsible of building an alert, he may build one alert every year, every 2 years. It's not something that is building every day, every week. So he will lose the competence of how to build it, where to connect. Sometimes he even will lose his credentials and so on. So it's really a real issue. So to keep them trained, it's really important. Doing like training sessions every week, it's really costly. No one will do that. And our system is really helping our customers or authorities to have automatic trainings, automatic evaluation, and adapt the training to the weaknesses of every agent. So this is the second point. And as I mentioned, as last, AI is not replacing human. It's a powerful force multiplier. So it will help the human react easily, faster, more accurately. And of course, we will always need this human to validate, the alert before disseminating it to the population. And the last thing is, I have one video that summarizes what we have mostly said in this
We live in a
session.
connected world, but not always a safe one. Climate is shifting, borders are blurring, tensions are rising, displacements, droughts. Inaction is not an option. But there's beauty in resilience. When crisis hits, humanity shows up. NGOs, researchers, frontline heroes, public and private partners working hand in hand. And there's technology. There's AI. It's not magic, but used right, it helps, it protects, it empowers. Introducing Intersec AI. Trained on massive volumes of metadata and enriched by cutting-edge AI models, it learns, it correlates, it detects, it predicts. Threat signals are buried in massive data, too hidden for the human eye to catch. You get insights, not noise. Intersec AI also reassures decision makers when stress peaks. Now, picture the first rumblings of an earthquake shaking a mountainous region. Emergency teams are under pressure, lives are at stake, time is slipping. Intersec AI steps in, fast, focused, and calm. It brings state-of-the-art situational awareness to trigger emergency procedures, draft the emergency alert, translate it into local dialects, turn text into voice for those who can't read, choose the right communication channels, reach everyone, even the least connected, and provide an evacuation plan. Built with ethics, focused on people. Intersec AI is still a machine, but it's a neat one. Intersec AI, intelligence that serves.
And that's it.
We live in a connected world.
I need just to go to the next one for questions. And yeah. Thank you.
Okay. It's time now for questions. Anybody in the room? Frank?
Among the problems that you're considering dealing with AI, what about the integration of the alerting system with, for example, a television station automation system that may be playing out the content for nationwide? Not a simple problem.
Yeah, when you mentioned television station is is it using it as a channel or using it because TVs today are used as a channel. We are already integrated with, we have a connectors, we have integration with TVs, with TV stations to broadcast the alerts automatically. But automatically, when I say automatically, of course, it needs always the human validation to post it or to broadcast it. As I said, AI will automate the process till the human validation. We will not go till the dissemination of the alert or the broadcast of the alert. So we will build it. We will choose the channel, of course. We will let the human change parameters if he needs. So we will build an alert. It's in edition mode. He can add a channel. He can type other things. He can adapt the message if he wants. And then he can submit it for validation and then validate it. So I don't know if,
Okay.
yeah.
Yeah. To follow up on the validation thing. So we've had some discussion about AI, and there's of course a lot of trepidation about to what extent do you just rely on the AI. So in the world of AI, there's the concept of a black box and a white box, where the white box means you could explain in a court of law why you gave that. Does your validation incorporate the idea that when we present a suggested alert, that the person who's reviewing that would say, okay, but I want to know why you thought there'd be a flood here, because I find that hard to believe. Is there a way to interrogate the suggestion?
Yeah, of course. So we are collecting data. We are keeping data. So if, for example, if we collect meteor data, we will keep the history of the data on our system. So when we decide that, okay, we assume that there will be a flood in this region, it's based on this data, and we will keep this data, of course. So
Oh, no, I'm saying, is that explanation that here's the topology, here's the amount of, water already in the ground and all that kind
Yeah,
of, is that immediately accessible for the person who's just validating?
Yeah, of course.
Okay.
On the system, we do have like a dashboard builder. We can build dashboards. We can show what data has been collected, what values are now accessible or has been collected from sensors, from other data sources. We have this, of course, we have this information, and then we have the decision why we took this decision.
Okay.
And this data is accessible on the system, of course.
So the other thing I would like to just draw the connection to the CAP-enabled infrastructure that we envision. Are you imagining or selling this product only to official alerting authorities, or really anybody who wants to buy it? So if Pinkerton's, who sells global intelligence services, says, hey, I want to buy that, and then in effect, they become an alerting authority, is that something that you are perfectly comfortable with? Or do you want to say, we really want this to be coming from officially registered sources?
As per today, we are only dealing with authorities, with governments, to be honest. So we have only governmental. So we work with operators through the governments also. So usually it's operator asked by the government whether they pay for it, whether it's the regulation of the country who will like make him installing a cell broadcast. So we can discuss this. It can be discussed in each government. So they have different policies, politics. But yeah, for now, we are only working with governments.
Okay.
I'm
frankly more
official agencies, of course.
From a legal and policy perspective, I'm a lot more comfortable with that answer than we'll give it to anybody who wants it, because then the whole issue of what's the real stuff from the official will get very, very murky.
Yeah, of course.
Quick.
Even when we see our alerting channels like cell broadcast, well, SMS can be used by other people, but cell broadcast, TVs, sirens, I think it's only official authorities or like governmental instances who can give us access to those. So we cannot really work with a private or private institution to do this to alert population.
Just to counter that, Facebook invented its own Facebook local alerts, and they decide who they consider official, and they put out stuff. Okay, anybody else? Tom, we got some online.
Actually, no, it's a question from me.
Oh,
first of all, I'd like a little clarification, and then I've got two follow-up questions depending on what your answer is. So first of all, in the slide, you showed that the AI was talking to the authority, let's say whoever that is, the fire service or whatever, meteorological service or whatever it happens to be. And then it said, this is the problem. Would you like me to send an alert? And then you'd waited for a response. So is that what it's doing? And then when it receives a yes, does it then write the alert? Is the AI writing the alert?
Yeah, sorry. So how it works, we built two kinds of alerts, of course. I can go a little bit more technical. So we have based on LLMs, agentic AI, and then we have our own machine learning, deep learning algorithms. Machine learning, deep learning is really to analyze the collected data like sensors, meteor data, and build some models like some local models to decide whether this collected information should trigger an alert or no. And then we have our LLM based AI, or we trained some LLMs. What is really common known is RAGs, like research augmented generation, which will use a language generation model and mix it with specific information. For example, with our documentation, with our software, how to build an alert, what the steps to build an alert, our APIs to build an alert. So we are mixing those, and we built really a chat box. So you can really discuss with the platform. You can say, okay, I want to build an alert. It will start the alert. You can choose the channels yourself. You can say, okay, I want it to be an SMS alert in 3 languages. This is the message. You can type it in 1 language, of course, and it will translate it to the other languages. It will build this. So it will really use our solution APIs and build the alert on the system. On our system, it will be visual, but behind it will be a cap message. So for the real thing is that we are building a cap message with all the description of all the fields of the cap message in a human language way and in a visual way, in order to make it easy and less. So it make it just easy to use.
Okay, so just to clarify, when the AI writes the alert, it writes it as a cat message after it receives permission. Is that right?
Yeah, so it will create objects one by one, the zone, the message, and then at the end, it builds a full cap message, of course.
Okay.
Yeah.
So the next question is to do with legality. So whenever the AI inevitably makes a mistake, especially true with LMMs, who is legally responsible? Is it the person who gave permission to the AI? What are you intending there? Because if it makes a mistake and that mistake is potentially deadly, you will get sued.
Yeah, of course. So we have different levels of validation in our system. So we have the alert, the one who will create the alert. So this is, let's say, this first level of verification. He should not be accountable. So he builds the alert, but he doesn't have the right to send it. So this is the first human using the system. And then we can define 1, 2, 3 different levels of validation based on the country legislation and based on what we want to do. We cannot make it very huge because it will take us 1 hour to validate the alert or to disseminate the alert. But I assume 2 levels of validation is enough. And for me, it's the 2 levels of validation who are accountable. Yeah, sorry.
So you're validating the human, but once the alert is given to the AI to be written, you have no idea exactly what's going to be said. And if it makes a mistake.
No, it's really the other way. I will build the alert and the human will validate. It's not the human will ask.
So the human will get to see the alert that the AI is about to send before.
Of course. The AI will never decide to disseminate the alert to the population. It will build it. The first one, which is the one who creates the alert, will see it. He can say, okay, it's fine for me. It looks nice. He will submit it for validation. The other level of validation, he will not even use AI. He is a human. He will see the alert and he will decide whether yes or no to send it to the population.
Sure, that's okay. So this will be required for every alert sent by this system, the human validation.
Of course. Yeah. There is always a human.
That's fine. Yeah. That would keep you legally safe. It's possible to make a variety of alerting systems that have automatically made templates that will behave automatically once the detection has gone off. So it is possible to go faster with a system not like this, but with this AI system, it would have to always get confirmation before it sent it off. Is that right?
Yeah. We do have templates, to be honest, in our system. We do have 2 things. We do have templates. We do have wizards. So template is really instantiate a full alert from an existing one. We do have wizards that will just help you create the alert with the steps. It will ask you what kind of alerts, what is the severity, what message channel you want, what's the content of the message. So it will help you build the alert in easy way. Those 2 ways make it faster, of course, but still needs decision from the human. Well, template messages are good. It make you gain time instead of typing the full message in 3 languages. It's already there. You need just to adapt it. But for us, it's still not fast enough. And especially, well, it depends on which part of the AI you want to use or you want to evaluate.
So you're saying the AI can help you write it, and it can give you info of that, but it can't have a saved template that automatically goes off once the situation arrives. Is that what you're saying?
Honestly, for me, when we use AI, we do have templates that can be used by human. We can use them by AI directly, but when we have AI, to me, using templates is just a detail because AI will build really the alert in few seconds. So using a template to make it 1 second instead of 3 seconds or 4 seconds.
But then you're going to have to confirm the template after it's been written, whereas the template's already been confirmed, so that can go out straight away. But this will always require a human to say yes.
Yeah, of course, of course.
Yeah.
Okay.
Yeah.
All right. Well, in that
Okay.
case, that's all my
Emma?
questions.
Thank you. Emma Perlson from GSMA. I have 3 questions.
Yeah.
One a bit smaller, just on the templates. So I'm curious, some of the work that I do on templating is building it with community members to understand if it's well suited specifically. Are you saying that the system, you're able to input that kind of information of if we're reaching to the specific community, it's a phishing community, they want this type of alert, and feed that to the AI?
Yeah, of course.
Yeah.
Yeah.
Okay, great. The second piece, I'm curious, in terms of, you said one of the things that the human is doing is selecting the channel. Is there any thoughts on having the AI be part of helping give a recommendation on what
Yeah,
the
of course.
most suitable channels are?
Yeah, it's part of it. It was in the presentation. So of course,
Okay.
AI will help the human to select the channels based on the criticality, on the type of the alert, yeah, of course.
Perfect. Thank you. And finally, then on the, just clarity on the CAP piece. So if it's helping to create then a full CAP alert, and then it's creating these kind of truncated versions for all of that, once this alert goes out, is it posting it onto these CAP feeds that exist that other people might be pulling from?
To be honest, this is really depends on the authority itself. As us, as a company, we can recommend things, we can propose things, we implement things. So our solutions always create the CAP message. It's ready to be posted anywhere they want, but we cannot really force them or do it without their okay. So we need them to ask us to do it. So,
but are you considering that as part of the system? Is that one of the things it can do is also, you know, once you click approve, post it onto this CAP feed that Elliot's shown us?
it's part of the system. In some customers, it's part of the system. So I will assume, yes, it's part of the system, but we cannot do it without the customer asking us. This is the most important part of it, because, for example, I can give a very quick example of France. So we have our system installed in a very isolated network. It doesn't have external connections to any other thing. If we want really to push it to any external website, they need first thing to open the flow, the network flow, which will go through a security process and so on. And also they need to ask us to push it. We cannot do it by ourselves. We cannot really force it. So it depends on our customers. It depends on the authority. We have some authorities really doing it by default. They ask us to send RSS feeds to the governmental website. They send us to send the CAP to any other, like to Google, to any other websites. So we do it. If they don't ask, if they block the feed, we cannot do anything on our side.
Okay, so
Yeah.
it is possible.
Yeah.
Great.
Thank you.
Thank you. Really interesting
That's great.
presentation.
Following up on that a little bit, in the presentation yesterday, I talked about CEN, the European Standards Agency. So they now have a requirement that if you're posting to Facebook or TikTok or any of the 50 or so other social media, there is always a link to the underlying CAP alert. So if you post to Facebook, you would say whatever you want on your Facebook post, but then here's the link to get to the actual CAP alert. So that's something you might want to build in, at least for your customers in Europe.
It's good because we build the CAP message for the authorities themselves. When we create an alert, we always keep a file, a CAP message for them to be used later or to be verified.
Yes.
Mostly for auditing, for internal auditings and other stuff. But we do generate it now to post it. For us, it's, to be honest, it's easy to post it.
Exactly.
It just needs the request from the customer. So yeah, if it's something standardized.
Well, in the European context, I think
Yeah.
you can tell your customers, this is actually a requirement in Europe.
Okay,
So,
perfect.
yeah.
Yeah.
That'd be good. And what that's going to help is when somebody just sees something on social media and it's just a snippet.
Yeah.
If they've got the underlying CAP alert, they can go, oh, I see what they're talking about, and it's not what I thought it was. Yeah.
Yeah.
So that because social media is generating more confusion,
Cool.
frankly, because so many different voices doing the same thing. One other thing that I would mention, this is on the LLMS that has cropped up a couple times. You could train it on the IFRC POPI, Public Learning and Public Education Messages. These are field-tested messages, and we've talked about them in previous CAP workshops. In other words, for about 50 different kinds of hazards in 39 countries and I think 30 or so languages, they've gone out and asked people after the fact, did you get the message? Did you understand the message? Did you take action that resulted in a good outcome? Only when all three are yes, does that set of instructions get put into this POPI. That's, I think, what your LLMS ought to train on.
Thank you. Thanks.
Now, you could obviously extend it into many, many more languages,
Of course, yeah.
but those are at least field tested, so they're a good source. I don't know, Emma, would you agree with that? That is a good way to go to use what the IFRC has already done in the POPI? Okay. The court will record that she was nodding. Anybody else? Any questions, comments? Is there anything else online? Tom? All clear.
Okay.
Okay, thank you very much.